We're going to be debating Grand Canyon and the features of Grand Canyon, so I want to show you what they are. Grand Canyon is 216 miles long, and it starts where the Little Colorado River joins the Colorado River, and it flows through the Kaibab Plateau. It doesn't flow around it, it flows through it. And then Marble Canyon is north of that. That's 61 miles long. And Marble Canyon is way different than Grand Canyon. It's narrower, it's steeper, and it's got side canyons that may be unique in all of the world. And then we've got the same elevation. I encourage people to go into en-us.topographic-map.com. And then wherever you click, you can get the elevation. So you can play around with this, see if I'm doing it right. The river flows into the canyon at 3,100 feet, and then it flows out at 1,200 feet. And yet in the middle, the Kaibab Plateau, it flows through at 8,000 feet above sea level. So it's a mile above the river on the north rim. On the south rim, it's 7,200 feet above sea level. And then you just go around over here, that's 6,000 feet, 4,100 feet, 6,300 feet, 5,500 feet. And then on the north, it's even lower, 4,300 feet, 5,200 feet, and 4,700 feet. And then we have this funnel right here, which is, we'll zoom in on this. This is where Vermilion Cliffs and Echo Cliffs used to be joined at one time. And now this funnel is formed, and it's 18 miles long and it's 12 miles wide. And I took a picture from that direction looking at the cliff. And you'll notice that it's 2,000 feet high, and the layers tend to slope upward toward Grand Canyon. And those white spots on the bottom at the base of the cliff, those are houses. And then this is, if you want to see this picture, go into YouTube and the Brian Nickel channel and check out the origin of Grand Canyon. He's halfway up Echo Cliffs. That's 12 miles over there to Vermilion Cliffs. And those cracks in the middle, one crack is the Marble Canyon, and the other one is one of those barbed canyons. And then if you look up the funnel, that's 12 miles wide. And then to put it in perspective, this is what Grand Canyon would look like. Grand Canyon would be a drop in the bucket compared to that funnel. And then we got potholes on Echo Cliff. And potholes are formed when a rock gets in an eddy or a vortex in fast-flowing water, goes round and round and cuts into the softer sediment. And these potholes are 3,300 feet above the river on a 2,000-foot cliff over 4 miles away from the river. And then we've got barbed canyons. These are very unusual. It's like the tributaries are flowing one way, and then they do a U-turn. You notice here, the big picture here, at the bottom, the elevation is 5,500 feet above sea level, and at the top, it's 4,000 feet above sea level. So the land is sloping to the north, and it drops 1,500 feet. And if you look at the individual canyons, this one drops from 5,500 feet to 5,300 feet, 4,700 feet to 4,500 feet, 4,600, and you get the idea. It's all sloping pretty much towards the north, and yet the Colorado River flows to the south. And then we've got side canyons. These are canyons that are just as deep as the river, and the northern canyons are longer than the southern canyons. And you've got the inner gorge, which is 1,200 feet deep through the hard crystalline rock, and that's a 46-mile gorge. And then you got a block near Isis Temple. It's 5 to 10 tons, and it's been raised up into sedimentary rock. And then you've got layers of sedimentary rock that are bent. And then you've also got a Grand Canyon caverns. They're 63 miles long. If you want to look at them, you got to take an elevator 21 stories down, and they're larger than 3 football fields. And then you've got Red Butte and Cedar Mountain, and these really aren't part of Grand Canyon, but they give a clue of how it happened. Red Butte is 1,000 feet of Mesozoic sediment capped with volcanic rock, and Cedar Mountain is similar, and you can see that from the Desert View Tower. And if you want to answer those, all you need for Grand Canyon is bulging and cracking 3 times. That's the key. 3 bulges, 3 cracks, and that explains Grand Canyon. But to set the stage, you need to have a lot of force to carve the Grand Canyon. Then that comes in the form of 2 huge lakes on the Colorado Plateau. Grand Lake's twice the size of Lake Michigan, and it's at 5,700 feet. So that's a mile in the air. That's tremendous potential energy, and it's incredibly deep. You know, you look at Grand Junction, Colorado, up on the right corner there. It's 1,100 feet deep. A little lower, Farmington, New Mexico, 350 feet deep. And then Page, Arizona would be 1,400 feet deep. This is a huge lake. It's very deep. And Hopi Lake's about the size of Lake Huron. It's 250 feet higher. And those cities would be under 900 to 1,000 feet of water. And then once Grand Lake started to breach and go over Vermilion Cliffs, it cut a slot through there. And then a lot of water is cutting through the slot, so it cut down a little deeper. So you get a whole bunch more water going through, so it cuts even deeper. So now the water's flowing through like a torrent, and that's how you get the potholes to form. And then it cuts the slot down to the hard Kaibab limestone, which is 350 feet thick. It can't go any deeper, so then it spreads out and makes this funnel, and it removes all that sediment. So there's nothing pushing down on the Kaibab limestone, so that bulges and cracks. And then the river flows through that crack and undercuts Hopi Lake. And now you got two lakes that are catastrophically draining, just sheet eroding almost everything off of the Kaibab limestone, except for Cedar Mountain and Red Butte. And then not only does the Kaibab limestone crack, but the whole Kaibab Plateau bulges and cracks. And then the river flows through the crack to carve out the Grand Canyon. But before we get that, let's take a look at the barbed canyons. You know, that when that plateau bulged, now it makes the land slope to the northeast. And that's when the subsurface water flows downhill to the northeast, and then it hits that crack and turns around. And that's how you get the barbed canyons. And you notice here that the river's cutting through below the water table. So now you get a lot of water coming in from each side, and then it's bringing with it a bunch of sediment, and that's how the side canyons form. And you'll notice here it says that the north rim is roughly 1,000 feet higher than the south rim. So that's 1,000 more feet of water to drain out of there. So that's why the northern canyons are longer than the southern canyons. And then the water's gushing through the cliffs, and it carved these caverns 66 miles long. And then it's carving through the Grand Canyon. And again, it's going down, down, down. It hits the hard basement rock of the Grand Canyon. It should have got wider, but it didn't. And the reason it didn't is because now there's nothing pushing down in the Grand Canyon. So the basement rock bulges and cracks. And that's how you get the inner gorge. That's a 46-mile crack in the basement rock. And then how does the National Park System try to explain this? You can see this for yourself. Go into nps.gov, and it says the story of how Grand Canyon came to be, blah, blah, blah. The story begins, blah, blah, blah. So this is a story, folks. This is not science like we think of science. We think of things as that are observable and testable, repeatable, falsifiable, the double-blind type of science. And this is none of that. You know, that's all high confidence science, but what we're doing tonight, that's none of it. It is low confidence science. They call it a story. I'll call it a story. I'd like to call it science fiction. And the heroes of the plot are the Colorado River. Notice this, scientists know that the Colorado River carved the Grand Canyon. Well, how do they know that? Were they there? Did they see it? You know, I'm here to tell you that there's no way that little river cut that canyon 10 miles wide. No way. So that's one of the heroes. The other hero is millions of years. Scientists have estimated an age for the river and thus the canyon through which it flows at 5 to 6 million years. So those are the heroes of the plot. But it actually admits on this national park website, perhaps the biggest question of all, how the Colorado River chose this course and began carving the canyon, still awaits a clear answer. So they don't know how it began. And perhaps the biggest question of all, I would disagree. I think it's, hey, how did this 5 to 10 ton rock get lifted up into sedimentary rock that's supposed to be millions of years old? And then how do these big layers of sedimentary rock bend at a right angle? And it says the Kaibab Plateau, a high point through which the river gingerly slices, poses a problem for geologists. Well, I never saw that when I was at the park. It says, what's the problem? Water certainly doesn't flow uphill. Remember, it flows in at 3,100 feet above sea level. It flows out at 1,200 feet. And yet in between, the canyon rises a mile higher than the river. Rivers don't flow uphill, so that definitely is a problem. I'm glad that they admit it, but it's not very prominent. You got to dig to find it. And it says, while keeping these few accepted chapters in the Colorado River's history book in mind, remember those chapters are the river carved the canyon and millions of years, geologists have proposed a number of different hypotheses. So let's take a look at them. Number one, the Little Colorado River hypotheses. In order for this theory to work, the ancestral Colorado River would have needed to flow eastward over the Continental Divide. Over that. Well, there's no evidence for that, so let's throw that one out. And you got the northwest flowing river hypotheses, and in the red it says, unfortunately, no sedimentary deposits have been found to support this theory. So throw that one out. And then the spillover theory, the catastrophic draining of ancient lakes. Now, that's the one I'm promoting tonight. You know, I agree with them, but they have the lake in the wrong spot. It says the Colorado River was temporarily damp behind the Kaibab Plateau. Well, if that's the case, it would have flowed around the north, which is thousands of feet lower than the middle, which is where the river cuts. So throw this one out. And then you got the collapse of a groundwater karst system. That's where I believe the water's gushing out of the cliffs and eventually it collapses down and makes the canyon. But if that's the case, there wouldn't be potholes on Echo Cliffs. So throw that one out. And so I'm not here to tell you what to think, but I'm showing you where to get information so you can think. And I encourage you to go into creationsciencecenter.org and page 247. And you'll see this for free. It's Walt Brown's 9th edition of In the Beginning. And then you can see all the theories on the top and all the features on the side. And then it's red, yellow, green. Red means, hey, this doesn't work at all. Yellow means maybe it does. And green means, yeah, it sure does. And you look under hydroplate, it's green all the way down. And so we want you to get all the information. You could also go into Real Science Radio, rsr.org, and listen to Grand Canyon Month and see how the river couldn't cut the canyon and how it's not millions of years old. And also you can even listen to Walt Brown explain it. And so again, bulging and cracking 3 times. And I'm just going back to this one. You know, my brother-in-law was in a geology class at a state university, and they spent a week trying to figure out how Grand Canyon formed. And they looked at a bunch of theories, and none of them worked. And then on Friday, the professor said—
1 minute left.
Okay. And Friday, the professor said, you know, there's one theory we haven't talked about. Anybody know what it is? The kid raised his hand and said, Noah's flood. And the professor said, yeah, you're right, but we can't talk about it. You know, isn't that interesting? They don't have a theory, but they won't even discuss that. And to be fair, this is not right after the flood. Things had to solidify so it didn't turn into a big bowl. You know, the Kaibab limestone had to get hard. So I'm proposing that this was a few hundred centuries after the flood. And so to wind it up real quickly, you know, bulging and cracking 3 times. That's how you explain the Grand Canyon. You know, you had 2 huge lakes up there. Once they started draining, they bulged at the funnel and it cracked, and then it undercut Hopi Lake, and then it sheet eroded everything called the Great Denudation. So then the Kaibab Plateau bulged and cracked. That's the second one. And then it eroded all the way down to the hard basement rock of the Grand Canyon. And so then the basement rock bulged and cracked. And that's how you explain Grand Canyon. And it just makes perfect logical sense. And I hope they'll put this on the National Park website, because the theories that they have there don't work. And they might as well put a theory there that does work. But I think we need more people to shine the light on that. So anyhow, that's the Grand Canyon in 12 minutes, bulging and cracking 3 times. Thank you so much.
Brian, thank you very much for that 12-minute opening statement. Lead the way in cross-examination. Gentlemen, the floor is yours. Brian, go ahead.
To form the Grand Canyon, you have to remove 1,000 feet off of 10,000 square miles, and it's called the Great Denudation. How did that happen?
I have no idea.
All right. What formed the funnel?
The funnel?
Yes.
I don't know. It looks like the Colorado River to me.
Okay. How do you get potholes on a 2,000-foot cliff, 330 feet, and 4 miles away from the river?
Well, I don't know exactly what that formation is, and I suspect it's not what you're saying it is, though. But I really don't know.
Why is Marble Canyon so much different than Grand Canyon?
Let's see. Looks like it's a higher elevation area. It's probably flowing down a little faster.
Actually, it's lower than the Kaibab Plateau. I mean,
Oh,
it's
right.
lower.
It is.
Yeah.
Well, that would also explain it. I guess it's a different elevation.
Okay. And how do you get barbed canyons? How do you get them to flow towards the north and then turn around and then flow to the south?
It looks like runoff again.
But why? I mean, the slant is going to the north, but that the river is going to the south. The land itself is slanting to the north. And when my brother-in-law was in his geology class at a state university, he said, this is one thing we could never explain. So how would you explain it?
I don't know, but I suspect it's runoff.
Okay, well, this is what runoff normally looks like. This is the Amazon. Okay, so then it drops down to 4,100 feet, and then you get to Nankowe Butte. Okay, this is 5,100 feet. How did that form?
That I don't know.
All right, and then this is that rock that we talked about, and you think that eroded up through millions of years of rock. Is that still your position?
It probably got rolled up as that formation was rubbing against the other one. Yeah,
it got rolled up there.
Probably
How long did those layers take to form?
A long time.
Millions of years, maybe?
Sure.
So how would a rock get rolled up through millions of years of rock?
Well, like I said, it's rolling through it.
Rolling through it, but you don't see the broken. You don't see the broken layers. You don't see the rock broken on the path as it rolled up. All right. And then how did Grand Canyon Cavern form? This is 63 miles long. It's 1,500 feet below the surface. How did that form through limestone?
Well, how did any cave form through limestone? There are limestone caves everywhere.
Yeah, it's because of the flood. The flood laid
Okay.
down the limestone, and then the waters gushed through it and carved it out. And then you get the stalactites and stalagmites forming after that. And the interesting thing about this is the largest dry canyon in the U.S. And this is huge. And then the other question is, where did all the limestone come from? You know,
Yeah, that is a good
Dr.
question.
Yeah,
Because limestone doesn't form rapidly, as far as anyone knows.
Exactly. And Dr. Walt Brown, he asked Bob Dietz, he's one of the founders of plate tectonics. He coined the term seafloor spreading. And when limestone forms, it releases carbon dioxide. And there's 600,000 times more limestone on the surface than carbon dioxide in the air. And so then he asked Bob Dietz, where'd all the limestone go? And you gave the right answer. Bob Dietz says, beats the blank out of me. And yet the hydroplate theory can perfectly explain how limestone formed. And this is what I was just told. So it's going to do 1 inch every 8,000 years, roughly. So my question to you is, how do fossil nautiloids form? They're in the bottom of the red wall limestone, and there's billions of them, and they're all pretty much oriented the same direction. And some of them are standing vertical. Okay, about 15% are standing vertical. And if that formed at 1 inch per 8,000 years, how is that nautiloid going to stand vertical for 100,000 years?
Well, you don't have to form it at 1 inch per million years. You can form sections of it faster than that.
So you're saying that they could have got buried rapidly. Is that what you're saying?
Yes.
Okay, we agree on that point. So that's what you're saying here, that all those layers went over the other one and sheared them off?
That's what the great unconformity kind of indicates, the great area of erosion.
Well, I would say it indicates that there was a big compression event and the basement rock buckled. And so the layers on top of that buckled. And then that compression event, they still kept going and the layers that were on top of it sheared it off. So that's another perspective. Do you think people should be able to see two perspectives or just one?
Well, if you have good evidence, you should see both perspectives.
Yeah, I would say so. Yeah, if you have good evidence, and I would say even if you make accurate predictions, I think that would be a good starting point. Are there any accurate predictions that your worldview makes or has made?
The whole fossil record.
So what do you predict? What prediction did they make, and what turned out to be true?
I would eventually predict, well, to go the other way with it, I would eventually predict to find a shark tooth in the Cambrian or the Precambrian, and no one ever has.
Okay, so that's one prediction that they have. Are you aware of any accurate predictions that has been made using your perspective of the past?
Well, if you look at molecular clocks and dates of transitional fossils, they seem to line up.
Well, that's not a prediction. Okay, and then you said that this Snevely Hill Formation, which is 800 feet to 1,000 feet thick, just eroded away in 70 miles. It's just not there. You think that just got eroded away?
Apparently it did, because there it is there, and there it isn't in the other spot. But
well,
there are
could
the
it
two
be that
sandstone and Harmon Formation.
Is it possible that these were not laid down over millions of years?
Not really.
So then how did this disappear? You just said it just happened to erode. Well, how come it didn't erode everything else?
Or maybe it didn't deposit. I mean, that's also an option.
That's what I'm saying. I'm saying they're not millions of years old. Then yeah, I would say that, okay, we can agree on that one then too. How did Red Butte form? 1,000 feet of Mesozoic. What?
I don't know how Red Butte formed. I'm not really familiar with Red Butte.
And I would say this is a remnant from the Great Denudation. Again, that's 1,000 feet of sediment that got sheet eroded off of the size of Vermont. And then the hydroplate theory, I mean, these two lakes draining catastrophically logically explains how 1,000 feet over 10,000 square miles, that would be 2,000 cubic miles of sediment got raised off. I would just ask you to consider that. And there's Red Butte. He predicts that the sand from the Imperial Sand Dunes will have come from the Grand Canyon. That's his prediction. And he also predicts that the inner gorge would be a tension crack. It's going to have a V at the bottom of it. And again, do you have any predictions from your perspective of the past, a blind chance perspective of the past, do you have any predictions based on that?
About the crack in the basement?
Any prediction? Do you have any prediction at all that we can look at and see if it's confirmed or denied in the future?
Let's see. I'm sure there are some. Mostly I have things like, why can't you find certain things in certain layers? And if you could, that would invalidate everything.
Right, but that's not a prediction.
Well,
What
it
do you
is kind of a
predict?
prediction.
What do you predict to be discovered that would validate a blind chance perspective of the past?
All right, I would predict that you would find soft-bodied animals in Precambrian, and I would predict that you would find things like arthropods in the Cambrian.
Have they found that already?
And
Have
that has been found.
Okay, so that's a post addiction. That's saying something after you found it. Is there anything that's unknown that you would say, that you would predict based on a blind chance perspective of the past?
That eventually, well, I don't know. I gave you two examples, and they're not really exactly what you're looking for. So
Well, no.
I don't know. I would have to think about it a little harder.
Right. And that's what the hydroplate theory does. It does make predictions. It's got about 50 of them. Fred McNam has documented he thinks that 20 of them have been confirmed. And that's the sign of a good theory, is if it makes predictions. And he said, Walt Brown says, if you don't make predictions, it's weak science, and it shows a lack of confidence in what you're teaching. Do you think that this theory of explaining the Grand Canyon should be presented for people to think about, since their theories don't work? Should this one also be theoried also be presented on the website and at the park?
I mean, I think you can look into how the Grand Canyon formed and everything and present it publicly. But when you start saying, well, it proves the Earth is 600 years old or whatever, I think that's a little bit different.
So if I hear you right, you would agree that multiple theories, including this one, should be presented at the park and on the website.
If you can present it in a way that doesn't say that doesn't totally go against other fields of science.
Well, we don't have to say how old the Earth is. We can just say two huge lakes drained to make this.
Sure, if you can prove those lakes were there and they really did that, yeah, teach it all you want.
Well, they've got theories there that they can't prove.
Okay.
They got four theories that don't work because they can't prove them. Could this theory be presented alongside of them?
I mean, you can teach it at church all you want to, I guess.
So you just want one theory to be taught instead of two, even though that theory doesn't work.
If you can get some really good evidence together for why the Earth is young and how all
this
these
has nothing to do. This has nothing to do with the age of the Earth. This is just.
I mean,
yeah.
The whole argument about Grand Canyon is kind of about the age of the Earth.
Well, they're claiming that it's millions of years old, and I'm saying that it's not. Okay, they've got one theory that they're teaching as dogma, so people just memorize and conform. I'm saying there should be two theories so people could think. Would you support an opportunity for people to think, or would you rather them just see one and memorize?
Well, I don't think anyone should just memorize things. I think you should go out and look for evidence yourself.
Okay, yeah. Well, to think you need to see. You're going to need to see two issues, two ways of looking at it. Could this one be presented? Would you want this one to be presented so people could see this perspective?
Well, like I said, if you can get some really conclusive evidence that lake,
it doesn't matter. They don't have conclusive evidence for the four theories right now. This one has very compelling evidence.
I can say that I don't have great evidence that the Grand Canyon was carved by a magic unicorn that wears a party hat all the time, but I could teach that.
But
one more question, Brian.
Okay. So if I hear you right, you don't want a theory that can explain the Great Denudation. It can explain why the layers are. We can explain the funnel. It can explain why it's carved into the hard basement rock, and a myriad of other features at Grand Canyon. You're opposed to that theory being presented along next to four other theories that don't work. Is that accurate?
Sure, we'll go with that.
Okay.
Gentlemen, thank you very much for a fantastic first cross exam and wrap up our thoughts. So, Brian, The floor is yours. Go ahead.
All right. Well, thank you so much for doing this. And when Grand Canyon gets brought up, this should be the first question that anybody asks. If the river cut the canyon, what cut the side canyon? Because they're just as deep and it doesn't have a river. And then also, why did the river cut through the plateau instead of flowing around it? And why did the river cut down into the hard crystalline rock of the inner gorge instead of getting wider like it should have into the softer sedimentary rock? And to answer all these questions, again, Grand Canyon is bulging and cracking 3 times. You got 2 huge lakes a mile in the air with tremendous potential energy. Grand Lake starts cutting between Vermilion Cliffs, and it cuts this funnel, goes down to the hard Kaibab limestone. It couldn't go any deeper, so it spreads out and makes this funnel that's 18 miles long and 12 miles wide. So that's a lot of sediment that's missing. So then that Kaibab limestone bulges and cracks, and then the water cuts through the crack and undercuts Hopi Lake. And so now you got 2 lakes that are catastrophically draining. This is how you get the great denudation. It's sheet eroding everything off of the Kaibab limestone, except for Cedar Mountain and Red Butte and a bunch of other places that are remnants of this. So then not only the Kaibab limestone bulges, but that whole area, the Kaibab Plateau, bulges and cracks. And then the water cuts through that crack, and it's cutting below the water table. So then you got water coming in from the side, which is bringing sediment with it. And that's why you get the side canyons. And then it cuts all the way down to the hard basement rock of the Grand Canyon. And there's nothing pushing down on it. So that rock bulges and cracks. And that's how you get the inner gorge. That's bulging and cracking 3 times. And contrary to what Jackson thinks, Thomas Chamberlain, he says that there should always be multiple working hypotheses. Otherwise, people will just memorize and conform instead of think critically. And my position is people should be able to think. They should be able to look at different theories and come to their own conclusion. Then again, the best place to do this is on page 247 of creationsciencecenter.org. Look at all the theories, look at all the features, and come to your own conclusion. Don't believe it just because I say so, but look at it and think about it and come to your own conclusion. Go into Real Science Radio, rsr.org, and listen to Grand Canyon Month and Walt Brown and Brian Nickel talk about how it couldn't have been millions of years and it couldn't have been the river. And other resources that I highly recommend. Number 3 there, Mission Imperative. That's Mike Snavely. Get this DVD. It's Grand Canyon Puzzle on the Plateau. That's a good intro to the Grand Canyon. And he talks about all those features of like Zion and Bryce that are part of Grand Lake. And then for your PhD in the Grand Canyon, go to Brian Nickel on YouTube, The Origin of Grand Canyon. Very well done, very well documented. A lot of the information, a lot of the slides are thanks to him. Then also his Genesis history, Mountains After the Flood. You're going to see that those layers bent while they were still soft because they didn't become metamorphic. And also go on to Grand Canyon trips. Creation Today had one. I went on it last year. It was great. You fly into Phoenix on Thursday, and then on Friday, you're on the river. And then on Friday, you're on the rim. Saturday, you're on the river. And it's so much fun. And then Sunday, I spoke at a church. And then I was on my way back home. So again, and then Starting Point to Project, they have one real similar. Plus, you get to go to Antelope Canyon. And then Mission Imperative has an 11-day safari going through all those different features, and he explains it perfectly with the hydroplate theory. Okay, so what do we do with all this information? Well, let's get it out there. This is your assignment. If you're convinced, or even if you're not convinced, if you want people to have an opportunity to think, go into National Park Service, nps.gov, go into Grand Canyon, and then you click Learn About the Park, go down to Nature, and then go over to Geology and click that button. Scroll all the way down to the bottom. You're going to see 4 theories that don't work, and it says, we will continue to learn. Well, let's give them something to learn, because at the bottom of the page, it says, was this page helpful? And I put no. I said, since none of the hypotheses work to explain Grand Canyon, please add the hydroplate theory's explanation. It logically explains many features, and see Brian Nickel's channel. So I encourage everybody to go onto this website, let them know their theories are a bunch of garbage. We want to see a theory that works, because this has happened before. They've taken out the Specimen Ridge plaque at Yellowstone. So if enough people point it out, it could change. We just want an opportunity to think. And then you go up to this one, Grand Canyon Geologic Formations. Scroll all the way down to the bottom, and there's that sentence that they hide really well, saying that they don't know how the river started, and they still awaits a clear answer. And then, was this page helpful? And you click no. And then you say, that's a false statement. There is a clear answer. The hydroplate theory logically explains the origin of Grand Canyon and the resulting river. See Brian Nickel's YouTube channel. So I encourage everybody to do that and get more and more informed. And basically, we just want people to think. Walt Brown, he says, widespread belief systems seldom change when frequently reinforced by influential institutions. Yeah, they seldom change when you're not allowed to think about anything else. Okay. And then he says, but when vast numbers of people realize they've been misled, an intellectual revolution begins.
30
And
seconds.
and that's what's happening. We've been misled. Grand Canyon did not take millions of years. They should put other theories up there so people can think, and then take a look and see who steps up to the microphone. And I do thank Jackson for stepping up to the microphone. It's rather rare. So again, when this comes up again, if the river cut the canyon, what cut the side canyons? And why did it flow through the plateau instead of around it? And why did it cut down into the hard rock instead of wider? And so that's bulging and cracking 3 times. And this is how you get to help make a difference. Just go in there and put a comment in there. So you want to think. You just don't want to memorize.
Brian, thank you very much for that.